All right, I gave you one example. I cut and pasted a couple of entries out of IST-IN Salion, which is the default log mode table. I cut out the CP Service Manager class log mode entry, which you can see maps to an APPN class of service of CP Service Manager and a subarea class of service of IST-VT-COS. You'll notice that this is the only standard subarea class of service name. It's the only class of service name that every one of your VTMs knows about. In all the other cases, all your subarea class of service names are going to be customized by you, so your cost names will have no reflection at all on what your adjacent customers' cost names are. But we know that this one is common because that's the class of service that's used for all SSCP to SSCP sessions, all SSCP to LU sessions, and SSCP to PU sessions. So we figured it was appropriate that if you happen to be doing APPN across the virtual route, you had a CP-CP session, you would want your CP-CP sessions to basically use the same transmission priority as your SSCP sessions would have. The second entry that I showed you was the IST-COS-DF entry, which is that default log mode entry. And again, it is basically a duplicate image of your default LU62 class of service. All right, so this again, it's used to map a log mode name to a subarea or an APPN class of service. This is the subarea class of service, and that's the APPN class of service. And again, the IST-COS-DF entry defines default values that you use when you have a log mode name, but you are not able to look it up and find it in any of the log mode tables that you're allowed to use. And finally, I also showed you an example here of an APPN to subarea cost mapping table. This says pound connect maps to blank class of service. Know that COS equals comma means the blank class of service. A blank APPN class of service is not allowed. It's not architected, it's not allowed. A blank subarea class of service is allowed. Pound bash maps to like a subarea bash class of service. Bash secure maps to something like SA bash secure. These over here are basically all the ones that you invented, your subarea cost names, the ones that you put into your IST SP cost and map them to virtual routes. And of course, if you had SNA Service Manager, you would want to probably map that one to IST VT cost also. It maps one cost name to another cost name. It's used in preference to the log mode table method if it's been defined. The default cost mapping can be used, so basically the default equals yes means that if I'm looking for an APPN class of service and I can't find a match here, I'm supposed to use the top entry as my match instead, so everything matches basically. It allows different mappings in each direction because you have to define a separate subarea to APPN cost mapping table if you want to. And if you want to map the blank subarea cost name to an APPN cost name, you just leave the label here blank on the subarea to APPN cost mapping table and you get the correct inverse mapping. A warning, do not include the CP Service Manager class of service in any of these log mode table methods. There are cases where we may actually use it twice inside the same network, and it's possible that you'll map it to something completely different, or worse, you'll take something that wasn't CP Service Manager and you'll map it to CP Service Manager, which can create serious problems in the network, obviously. CP Service Manager is a very specialized class of service. It can only be used for CP-CP sessions. All right, and one more table that we have here actually is the border node cost mapping table. The border node cost mapping table is our way of mapping an APPN class of service in one network to a corresponding APPN class of service in another network. The first thing I want to tell you is this. If both APPN networks are using only the standard APPN class of service names, then you'll never need anything for a border node cost mapping table. They will not be needed at all. And that is the way I would definitely recommend that everybody go. But if for some reason an adjacent customer has two different types of interactive traffic and they want to be able to separate them, they might create an interact and an interact 2 and map those to pound inter and pound inter 2. And if they both map to pound inter in your network, then when you go back, you may not always choose the right class of service name. So the bottom line is, if he's got two different kinds of interactive traffic that he wants to keep isolated, and he wants to send both of those through you, and he wants you to keep them isolated, then you will need to define a second interactive class of service name for that also. That's the only way you can do it. Whenever you do blue border node cost mapping tables, they're actually inverse mappings. Sometimes we have to map from our net ID to the adjacent net ID, and sometimes we map from the adjacent net ID to our net ID. We always use the same table for both of those mappings. If the adjacent net ID is net B, then I'll pick my net B table. If I'm mapping net B to net A, I'll go one direction. If I'm mapping net A to net B, I'll go in the other direction. But the bottom line is the same table is often used for mapping in both directions. And that's why it's best, by the way, to make sure that your border node cost mapping tables are one-to-one mappings and invertible. Okay, so who performs the border node cost mapping function? For extended border node boundaries, there's a border node on both sides, and clearly only border nodes can do the cost mapping function because guess what? Network nodes don't know their border nodes, and so they don't even know what cost mapping is all about, right? So it has to be a border node who performs the cost mapping function. On an EBN to EBN boundary, since we've got border nodes on either side, the extended boundary, either one of them could do it. So on locate flows, we typically always want this to happen on the secondary LU side of the network. So on locate flows, the mapping is performed by the EBN on the SLU side of the network. So if it was a SLU initiated session, it would happen on the OLU side. If it was a PLU initiated session, it would happen on the DLU side. On route setup flows, route setups are used to establish RTP pipes. And if RTP pipes span network boundaries, we may have to do cost mapping for them as well. Route setups almost always flow in the PLU to SLU direction, and so we always do those on the destination LU side of the border node on the destination LU side, because that is typically the secondary LU side also. Remember, your border node cost map tables must perform inverse mappings. You do not want the same class of service name showing up on both, more than once on either the left or the right side, or else you have a 2-to-1 mapping or a many-to-1 mapping, which you don't want. For peripheral network boundaries, that's a border node on one side and a plain old network node on the other side of the network boundary. Well, there's only one border node, so the border node is always the one that has to do the mapping. And that's the reason why sometimes we have to map from the peripheral net ID into our net ID, and sometimes we're mapping from our net ID into the peripheral net ID. So there's at least one good case where we have to use that mapping table in both directions. In fact, that's what I said at the bottom. The same BN cost mapping table is used to map in both directions when you're using the peripheral boundary.